Hello, hello. Did you have a good weekend? Good Mother's Day weekend? Hopefully, yes. I got some magnificent flowers. You can see them. They're pretty cool. Yeah, pretty sure they're made out of egg cartons, but very well loved. Oh, and I got this drawing, which says, Mom is the superest mom in the world, and clearly has us standing on the world, so that's a keeper. Okay, today's plan is, if you're interested, you can do the extra credit puzzle. I know a few of you always do it, which I think is cool. It's also why I keep doing it, so thank you for participating. The video is a little longer than usual. I think it's like 20 minutes, but it cut off like the last minute at the end, but I think you'll be able to figure out the example. There's actually two links on the site today. One is the example puzzle and one is the actual puzzle. So make sure you look at the example puzzle first when you're looking at the video with me. All right, so we're going to do the second part of the 8.2 notes today. And then you have a short homework assignment, which is 3 problems. So, first thing we're going to do is go back to that first page of notes that we took together. Because this time we're going to be doing where the variances are equal between two populations where it's pooled, and we're going to put a giant formula right here. Definitely the worst formula that there is in this book. So here we go. T is equal to giant fraction with so much room on the bottom. On the top is going to be x bar 1 minus x bar 2 minus mu 1 minus mu 2, which is 0. And then on the bottom, we've got a giant square root times a lesser square root, but still pretty big. And underneath the first giant square root is n1 minus 1 in parentheses. And the first standard deviation squared plus n2 minus 1 in parentheses times the second standard deviation squared all over n1 plus n2 minus 2. And that gets multiplied over here times 1 over n1 plus 1 over n2. So, how gross is that formula, huh? And here's the degree of freedom right here. So make sure you outline the degree of freedom and write down this formula. Pause the video if you need to. Alright, I'm going to assume that you have it. So now we're going to go on to doing that last problem on that last page. It says that a manufacturer claims that the mean operating cost per miles of its sedan is less than that of its leading competitor. Okay, I'm just going to write my H sub O and H sub A right now. So let's see, they're claiming that their stuff is less than their competitor. That's the claim. The other one is greater than or equal to. I suppose I probably need some stats for this information since I didn't write it down in the first place. So, the manufacturer, here's their stats. Their X bar is 52 cents per mile. Their standard deviation is 5 cents per mile, and their sample size is 30 cars. And then their competitor has a mean of 55 cents a mile, a standard deviation of 7 cents a mile, and a sample size of 32. Okay. I can definitely do this problem because if you look at all the information, both sample sizes are bigger than 30. So that's good. And it's randomly selected. Population variances are equal. Okay, so this is a left-tailed test because over here that H sub A is less than. So now I have to use that degree of freedom. Remember that degree of freedom from the first page is you take the two samples and then you subtract 2 sample sizes and subtract 2. So 30 plus 32 minus 2 is 60. So on page A18, I'm going to look at a one-tailed test with alpha being 0.05 and my degree of freedom is 60. And if you look that up, you get 1.671, but you got to add a negative to it because it's over here on the left side. So that's negative 1.61. Negative 1.671. All right. So the next thing we have to do is we have to actually find that standardized test statistic with that horrible equation. So here we go. I've got the equation to the left, so I'm just looking at it, but you're going to need to have your equation out looking at it too so that you can follow along. So the top of the fraction is x bar 1 minus x bar 2, and then minus mu 1 minus mu 2, which is just 0. And on the bottom of this horrible fraction, we've got 2 big square roots. All right, the first one is n minus 1, which is 29, or n1 minus 1, which is 29, times 0.05 squared, because that's that first standard deviation squared, plus 31, that's n2 minus 1, times 0.07 squared, because that's that second standard deviation squared, all divided by the sample sizes added together, minus 2. And then over here we have 1 over the first sample size and 1 over the second sample size. Now, that is a super gross formula, and it's going to take a lot of different calculations in your calculator, taking it nice and slow. But if you do it correctly, you end up with t equals negative 1.93, which hits right about here, which means that we're going to reject the null and accept the claim. So I'm going to write here, I reject the null and accept the claim that the manufacturer mean cost per mile is less than their competitor. And that's the conclusion. All right, so now what we're going to do is we're going to kind of restart this problem and just show you how you would do it with a calculator, because realistically, especially on the AP exam, there is no way that you would do this calculation by hand. It takes too long to write it out, too long to figure it out on your calculator. You might as well do it with your calculator. So, all right, so there's my calculator. I'm going to go to Stat, over to Tests. Make sure you do this with me, don't just watch. You're going to pick 2 sample t-test right there, just like we did last time. Remember, data is if you had like a whole bunch of data in a problem, like your last homework problem will be, then it can pull directly out of those lists. Stats is when you type it in yourself. So x bar 1, I've got it all filled in here, was 0.52, S1 is 0.05, N1 is 30, x bar 2 is 0.55, S2 is 0.07, and N2 is 32. I picked left-tailed because it's a left-tailed test. Remember, you always highlight the H sub A. And it is pooled, and remember, pooled here means that the variances are equal. So that's what pooled means. I prefer to draw it because I like to see it, but you could just hit calculate and get a t-score and a p-value if you were to wish to do it that way.